All right, moving on to the 7.3 notes, where we're going to cover function notation. All right, so after this lesson, you should be able to evaluate a function written in function notation. Vocabulary. A function rule is an equation with two variables that describe a function. Input values, and those are your independent variables that you plug in, usually the x values, while the output values are the dependent variables that you get once the function is evaluated. Those are your y values. When evaluating functions, you're going to first substitute the input value in the formula with the given value. You're going to then evaluate the expression. That means you're going to be doing whatever computations the function entails. And finally, you're going to gather your ordered pair. All right, so example number 1 says, given the function rule y equals 3x plus 5, find the output for each given input. Gather the ordered pairs. All right, so for part A, we're given the input as 0. So that means we're going to take that input value, which is our domain, which is our x value, plug 0 in for x, and then we're going to evaluate. So that leads us to an output value of 0. So now we're going to gather our ordered pair. The ordered pair, our output value is going to be y equals 5. So now when we gather up our ordered pair, it's going to be 0 for the x, 5 for the y. Let's skip over to part C, where there's an input value of -5. Again, that input value, that is our independent value, that is our x value. We're going to plug that -5 in for x. All right, again, to find our output value, we're going to evaluate, meaning we're going to do the operations on the right. All right, so there's our output value. So now the last thing we need to do is gather up our ordered pair. Our input value was -5. Our output value is -10. So -5, -10 is our ordered pair. Now example number 2 says find the range of the function y equals 2x squared minus 3, whose domain is these 5 values. All right, so what we're going to do is we're going to take every one of those domain values, plug it in for x, evaluate, and find all the respective y values. So we'll start with the first domain value of -4. We're going to plug -4 in for x and then evaluate. So again, make sure we are remembering to follow the order of operations here. All right, so when we do that, we get an output value of 29. So now what we're going to do is we're going to repeat that same pattern about just plugging in these different domain values. All right, so here are all 5 of the output values that we get when we plug in those different domain values. So now we need to arrange these in a set, and it's going to represent the range. All right, so while we do see a couple of these values repeat, you do not have to write them again. So here on the line, I have the domain of the function in set brackets -3, 5, 29. Those are the values for the range of this function given that specific domain. For example number 3, we're going to do the same thing. So we're given the function y equals -2x plus 4. And for part A, it says we want to find the range of the function if the domain are these 4 values. Okay, so once we do that, we're going to move on to part B, where it says use the domain and range to gather up the ordered pairs. And then part C is going to be asking us to go and plot those to see what the graph looks like. So here are all the range values. So now we're going to pair them up accordingly with the domain to make ordered pairs. All right, so there are the ordered pairs. Now we're going to go ahead and plot them on the graph grid. So there's our 4 points. So now we're going to go ahead and connect them. And we see that they create a line segment. All right, so let's move on to example 4. It says, suppose your summer job pays you $4.25 per hour. It says, write a function rule for your total pay given the total number of hours. Well, before we do part A, let's go to part B, where it says, what does your independent variable, your input value, represent? So again, for independent variables, we are usually going to use the variable x. All right, and then for us, the independent variable is going to represent the number of hours you work. All right, so x is our independent variable, and it's going to represent the number of hours we work. Part C says, what does your dependent variable, your output value, represent? Again, for us, that's going to be y, and that's going to represent our total pay. X represents the number of hours worked, while y represents the total pay for those hours worked. So let's go and move back to part A, which says, write a function rule for your total pay given the total number of hours. All right, so again, to figure out the total pay for the hours we worked, y equals, we're going to take the pay per hour, which is $4.25, times the number of hours we worked, x. So our function rule is y equals 4.25 times x. All right, let's move on to the next page of notes, where we're going to begin with function notation. So all function notation is a change in the way we write our dependent variable. So again, in all the functions that we've written, it was always y equals. So now we're going to replace y with the function notation f parentheses x parentheses. And the way you're going to read that is f of x. The way you're going to read that f parentheses x is f of x. So now what we do in terms of evaluating a function using function notation, it's not going to change. It's just the way that the information is going to be given initially to start the evaluation. So take a look at example number 5, which says given f of x equals 3x minus 5. All right, so there's our function written in function notation. Part A says find f of 0. F of 0. So that means we're going to go to our function and we're going to plug 0 in for x. All right, so that's all that means. F of 0 means go to their function, and wherever x is, we're going to plug in 0 for x. So then we're going to go ahead and evaluate. All right, so when we follow the order of operations, we get -5. So now what we need to do is pair up our function notation with this output value. F of 0 equals -5. I want you guys to get used to writing your final answer for these evaluating the function using function notation problems this way. All right, so f of 0 equals -5 is the way you should write your final answer. So to find f of 6, we're going to take 6, plug it in for x, and evaluate, and we get 13. But then when we write our final answer, it's going to be f of 6 equals 13. So now here in example 6, we are given 3 different functions. We have f of x equals negative 5x plus 2, g of x equals 2x squared minus 4, and h of x equals 2 to the x power. All right, so what I want you to do is take the time here to see if you can evaluate these 4 or these different functions here to start. Okay, let's start with the first 3. Find g of 3, f of 8, and h of 3. All right, so for g of 3, we're going to take the g of x function, and wherever x is, we're going to plug 3 in its place, and we evaluate, we get 14. So g of 3 is equal to 14. All right, so again, that means we're going to take the input value of 3, put it in the function, and get an output value of 14. f of 8, taking the f of x function, plugging 8 as an input in for x. And when we do the computations, we get negative 38 as the output. So f of 8 equals negative 38. Again, 8 as an input, we get an output for the function of negative 38. h of 3. So we're going to take the h of x function, plug 3 in for x. And here, x is an exponent. So we get a value of 2 to the third power, which is 8. So h of 3 equals 8. Evaluating the function h at an input value of 3 gives you an output value of 8. So now we're going to finish up here with this next one, f of 4x minus 3. So again, we see that the input value is an algebraic expression, but that should not change the way you evaluate functions. So instead of the input being just the number, here we have an input being an algebraic expression. Again, all this is saying take the f of x function, negative 5x plus 2, and wherever x is, we're going to plug 4x minus 3 in its place. So again, the x in the f of x function is next to the negative 5. So in next to the negative 5, we're going to plug 4x minus 3. All right, the input is an algebraic expression. So now we evaluate. Distribute the negative 5 through the parentheses to get negative 20x plus 15, and then the plus 2. And then we combine like terms to get negative 20x plus 17. So our final answer for that problem is f of 4x minus 3 is equal to negative 20x plus 17. So if you take the f of x function, put an input of 4x minus 3, the output is negative 20x plus 17. All right, that's it for today's lesson. Move on to the 7-3 homework.